fantastic to be here, the very first KubeCon in India. And thanks to Arun, he set this stage for what I'm going to cover. So let me start by asking a very quick question. How many of you use ChatGPT on a day-to-day basis? Wow. OK. So if you are using ChatGPT, let me tell you what's going to come next. So we are going to deal with something called an agent in 2025 and beyond. So agent is going to be the next big fundamental shift that's going to take place in the AI landscape. But what exactly is an agent? So before I really explain what an agent is, let me walk you through the journey where the data has evolved to become more actionable. So it all started with spreadsheets in 1980s. Spreadsheet just represented data. Something like 5,000 Acme Corp deal closed. Now, it was just data. Then in 1980s, we moved to relational database, and that started to turn data into information. So spreadsheets were just capturing data. Databases turned that into information. So data plus context becomes information. So over a period of time, sometime in 2000, we moved from simple information to knowledge. So knowledge is where you actually bring much more contextual data or context to the already provided information and make it much more insightful and much more actionable. So that is basically the data warehouse that we have seen, where you can actually say, now that I have historical data, how do I perform some kind of insightful queries? For example, which product has been selling the most, which enterprise product has been taking the longest cycle, and so on. So that actually gave us the knowledge. Then in 2010, big data and analytics came into the picture. So this is where we turned knowledge into insights. Remember Hadoop, Spark? That basically converted knowledge into insights. So companies and enterprises went multi-channel. They started capturing data from mobiles, desktops, web, existing applications, the CRMs, ERPs. The landscape has become extremely large. And that's where we started to build data lakes and started to build analytics. So that gave us insights in terms of dashboards, visualizations, and so on. And then came in AI, which brought in predictions. So now you can actually use machine learning models to actually figure out when the deal is going to be closed or what could be the potential objection from a customer and how long it's going to take for this deal to get closed and so on. So that was the infusion of AI into insight, and it became intelligence. But intelligence always wanted a human to take the action. For example, if you are using Salesforce and if you apply intelligence to it, it will tell you this deal is going to be closed if you approach so-and-so influencer or the champion within this account. And if you actually provide these inputs, you might close the deal. But someone will have to take that action. Someone will have to send that email, pick up the phone, talk to the person in that enterprise, and close the deal. That is the action part, which is typically left to a sales rep or a human. Now, guess what? With agents, we are going to convert intelligence into action. So agents are going to be basically taking the last mile approach, where they not only tell the human to perform something, but they go ahead and perform the task. For example, in the sales scenario that I've been talking about, an agent can actually send out an email to the customer, negotiate with the customer, modify the quote, and do everything that a typical sales rep would do to bring that almost to the closure. So the agent is the latest evolution in the data pipeline, and that's going to close the loop by performing actions. But what exactly is an agent, and how is it structured? The simple analogy that I want to give you is, if you think of GenAI as an operating system, LLM is the kernel, and agents are the apps. That is the new stack we are going to deal with. Very similar to how an operating system is structured, But here the kernel is going to be the large language model. The RAG tools and a variety of embedding models and all of that that Arun has showed is going to be the shell. And the agents are going to be the new apps. So in that world, the agent is going to have certain attributes. Its brain is going to be powered by an LLM, the large language model, like a GPT-4o or a Llama model. And it is going to make a lot of decisions dynamically. That's very important. The agent will have memory because it needs to retrieve contextual information from database or a file system or a persistent store. And it also applies reasoning to basically think strategically and take the next step. And finally, it will close the loop, which is an action. Now, let me give you an example of this. An agent in an insurance scenario could actually take the help of an LLM, and it might actually process a claim as long as the value is below a certain threshold and the claim has certain parameters. So this definition is going to come from the LLM, which is going to guide the agent. And then it also looks up the memory to basically think whether similar processes were made earlier, similar decisions were made earlier. And then it's also going to reason why that claim should be processed immediately. And it will send out an email saying your claim is processed. But if there are issues with the claim, it requires escalation, it can send a Slack message to a representative who will review it and basically putting the human in the loop. So that is how the AI agent is going to evolve. And if you actually carefully analyze, the agent is a lot like a container. Now let me draw an analogy here. If you look at the container, the bottommost layer of a container is the OCI runtime. Well, for the agent, the bottommost layer is an LLM. Now, if you take out the OCI runtime out of a container, the container is nothing, right? Similarly, if you take out an LLM out of an agent, it is nothing. So there are a lot of similarities. Now, microservices are when we bring a bunch of containers together and try to make them work, there is a deterministic path. There is a deterministic logic. Now, call microservice 1, then call 2, then call 4, and if the output is this, call 6. So basically, there is a well-defined path. Whereas an agent has an adaptive logic that is going to be determined at runtime based on a variety of cases. And then containers are stateless by default, whereas agents are completely stateful because they need to have memory. They need to retrieve data based on the past execution and also to persist their own execution as they go along. And then the container is a static resource. You can actually define how many CPUs or CPU cores you want, what is the memory that you want this container to consume. So it is well defined. Whereas an agent can be very dynamic. It can actually consume a lot many resources during its execution. And the container is going to have identical replicas. For example, when you scale out a deployment, you're going to see multiple replicas, and each of them are identical. Whereas an agent is going to be very unique. Every agent is unique, and every agent will have a persona. An agent can be a specialist doing something, an insurance claim processing agent, or an analyst or a researcher. So an agent has a persona, whereas a container doesn't have a persona. It is just a replica of the original definition. But as you can see, in the current landscape, in the current context of agents, we are almost at the same phase as Docker run of containers. I'm talking about 2014, when we're all excited about a single Docker run command, at the most linking 2 Docker containers with a link that Docker CLI gave. But very soon, we realized microservices are a collection of containers, and just a Docker run command won't cut it. We need to go beyond Docker run, and then came in Docker Compose, Docker Swarm, and then Kubernetes happened, and now we use Kubernetes for orchestrating tens of thousands of containers and microservices. Guess what? Agents are experiencing exactly the same evolution. Today, the world is excited about running one agent. which is powered by one LLM, one specific definition, and a persona. But to really perform enterprise-grade agentic workflows, one agent won't cut it, just like one container won't cut it. So we need to have multiple agents working together in tandem, in concert, to accomplish a specific workflow. And that's exactly where we need orchestration. So agents are very, very similar to containers, and we are going to face exactly the same set of challenges like resource conflicts, communication chaos, state management, version confusion, and very opaque execution cycles. And guess what? We have been there, we have seen that, and we have done that. And it is containers all over again. And that's exactly where Kubernetes shines. Kubernetes is amazing when it comes to resource management, coordinated interaction, persistent storage, version control, observability. So we have all these building blocks and primitives built right into Kubernetes, and agentic workflows and agentic world is going to deal with all of this. So why not use Kubernetes to actually orchestrate agentic workflows? So that is the forward-looking view that I want to present. And Kubernetes is not new to this. It has already become a universal control plane. From orchestrating containers through pods, orchestrating VMs through KubeVirt, orchestrating cloud through Crossplane, orchestrating WASM components through a variety of projects, orchestrating databases, even orchestrating IoT edge. So it is basically becoming the front and center of orchestration and process management. Now, agents are going to be yet another workload type that Kubernetes is going to orchestrate. It is very well positioned to really take care of this. So the high-level architecture that I'm proposing here is we're going to write an agent controller that's going to have two components. One, an LLM primitive, which is coming from the AI building block section, and a typical traditional Kubernetes controller. So, for example, if you are running an agent that says, analyze the logs, metrics of my workload and tell me where is the performance bottleneck. Now, this single instruction to an agent will basically expand into multiple steps. You got to look at your Prometheus metrics. You got to look at your log analytics. You need to look at a couple of other databases or metadata stores, and then come back with an analysis on what's going wrong. So who will determine these are the steps? That's the LLM. So the LLM is going to take one instruction, break it down into multiple logical steps using some strategy like chain of thought, reflection, or a React pattern. And it's going to say, these are the 5 steps that you need to execute to accomplish this single task. Now, each of those steps will become a persona for a new agent. Now, that comes back to the agent controller, which is a Kubernetes native controller. And guess what? Here, every step that the LLM is recommending is going to be turned into a new agent, which is nothing but a container, a pod, and the agent controller is going to spin off those many agents, and they keep running. They are almost like run-to-completion jobs. All of them will execute in tandem. One will go after a low-key metrics, one logs, and one will go after the Prometheus metrics. One will go after looking your Grafana visual dashboards, and then all of them will come back and consolidate their outcome, and then you're going to see a specific pattern that's going to highlight what is going wrong. So this is actually working with the LLM and the Kubernetes controller in tandem to accomplish a task. And there is going to be an agent CRD, a CR, a scheduler, and all of them will feed into the observability building blocks. And we're going to see something similar to this. Now imagine kubectl apply agents.yaml, and your agents.yaml looks like this. If the font is too small, this is exactly where you'll define the agent definition almost as a CRD. So you'll actually have the task, you have the model, you have the memory, and the tools. Now, those are the building blocks of an agent. You define all of that in a YAML file. You submit that YAML to the API server. It goes to the controller, and it actually asks the LLM to break it down into multiple steps, and then the execution kicks off. It gets completed, and you can use kubectl primitives to basically track this entire thing. So this is where agents meet Kubernetes, and Kubernetes becomes the orchestrator of the agentic workflows. This is a very exciting world where two different worlds will converge. One is a proven, stable, production-grade orchestration environment, which is Kubernetes. One is evolving, non-deterministic, highly dynamic world, which is the agentic workflows. And this brings both of them together. So we have multiple investments already made in this world. This is the agentic workflow landscape. For example, there is a tool called Prefect, Crew AI, very popular. Then we have Dagster, Metaflow, and Apache Airflow. These are some of the existing Python-friendly frameworks to manage agents, but they have no capabilities of Kubernetes. And then we have the cloud-native ecosystem gearing up to handle this. For example, Argo workflows. We can already create a DAG within that. Dapper workflows, which is currently in beta. Then Numa Proj, which is another mechanism to orchestrate real-time data pipelines. And of course, Kserve, which came out of Kubeflow. So these two ecosystems need to merge, and that's exactly where we are going to see Kubernetes becoming the universal orchestrator, not just for containers, pods, and VMs, but even the emerging agentic AI workflows. So that brings us to the discussion, the end of the discussion. Thank you.